All right.
It's just B2?
One of them will come up.
Good. So this is the DSC. DSC stands for Differential Scanning Calorimeter. So what this is a way to measure heat flow of your sample. So the DSC, you'll have your cell here. So this is where all your measurements are getting taken. You'll have a cover over top of that. And then inside of here, you'll see there's a silver lid. So all this cell is made of pretty much silver. And then if you take this lid off, you'll see there's two small sensor platforms. So if you see in there, there's two platforms. So one is for your reference, the back one is your reference, the front one is sample. So the way I've always told to remember that is kind of stupid, but you keep your sample close to your heart. It's dumb, but it's a way to remember it. Reference in back, sample in front. So whenever you run a DSC test, you're going to have two pans always of the same type. One of the pans is going to be empty, which is the reference pan, and one of them is going to have your sample in it. So whenever you run that, again, you always have the same type of pan. You can rerun with the reference pan. The sample, however, you're going to dispose of the sample after you run it. So you can always just leave the reference pan in there if you like, and just have a new sample every pan every time. One thing to note about the cell is that since it's all silver, it's very easy to nick the surfaces of it. So the cell lid, you always want this surface to be very smooth, as well as the surface in the cell that it sits on top of, because that can affect your signal. So whenever you go to handle this lid, just be very careful. Don't ever put the lid on the plastic down like that. Always try to get it upside down. It's kind of awkward to maneuver it, but always just at least try to be careful of that edge whenever you change samples. And try not to leave the cell open to the environment for too long. So whenever you load a sample, just have it prepped, ready to go. When you have your sample prepped, then you would open this up, take the lid off, load your sample in, and try and get the lid on it as quick as you can. Easiest way to do it is just with these tweezers. You may find a better tool for it, but this is the tweezers we provide. So, and then once you put the lid on, it's just simple as putting that lid on. Once you get your sample in there, you would just start whatever test you have programmed. It's pretty much simple as that. This cooler right here allows for the operation for sub-ambient, so you can go negative 90 degrees Celsius with this cooler, and with this unit you can go up to 450 C, so full range negative 90 to 450. Cooling rate, or rates of heating and cooling vary, so this thing is not a linear ramp rate all the way to negative 90, so it's going to slow down. It's going to take a while for it to get all the way down to negative 90, so be wary of that when you're programming cooling runs, that you don't exceed the capacity of the cooler. Another thing on here is the gas lines. So this always needs nitrogen to run.
Yes.
It's always going to run.
Always activate.
Yeah, so the regulator you have isn't ideal. It's a pretty high pressure regulator, so I highly recommend you get a low pressure regulator so you can fine tune it to 20, because right now it's kind of just eyeballing it. It's barely enough, like almost on the verge of not even being on, that it's so low. But yeah.
How do you tell whether it is enough? The machine will tell you?
On the software, I'll show you in a minute over here. But yeah, you always want the nitrogen or some kind of inert gas. There is ports on the back, so you have a gas 1 and a gas 2 port on the back of the instrument. So if you ever wanted to expose your sample to oxygen or any kind of stuff like that, you can add in another gas to do that.
Yeah. So this is the port.
So the ports are on the back. If you look, they're labeled. So you see gas 1 and gas 2 and cooling gas. You don't really have to worry about cooling gas because you have the RCS cooler.
And it doesn't matter what kind of inert gas you use. So it
You
doesn't
can use
matter
nitrogen or argon. Usually those are the
It
two.
doesn't depend on the materials
It could depend on that. I'm not sure what kind of materials you're running. That may be something you'd have to talk to our applications team about. But maybe it's kind of a more higher level question. Something that I couldn't answer. I'm sorry. But typically nitrogen and argon are the two ones. But I don't know, depending on your sampling.
And we don't need to fix This one is just like this.
It doesn't have to be perfectly centered as long as it's just on there. It should be fine. So with this, when you come in, you can choose to have this cooler on a few modes. So depending on how often you run it, you may find you have to turn off the cooler. So if you're only going to run it like once a month, it may be best to turn off this cooler.
Does it fill with like acid glycol in those?
It's refrigerant. I think it's, I forget the exact refrigerant.
Or something. Or 34 or something.
Yeah, or I think it's Arctic, something like that. 124. It's all enclosed, so you should never have to open this up to do any of that. There's really no real maintenance with this besides cleaning these fins on the side. So depending on how dusty your lab is, you may find you have to vacuum this fin out. That's really the only maintenance you have to do with this. There is another thing with this. There's a graphite gasket on the cell that seals it. Usually that doesn't really have to be ever changed unless you take off this cooling head. But I'm assuming you'll probably just leave this setup on here, so you'll probably never have to really mess with that. Luckily, it's pretty low maintenance.
We're gonna have the 100 pop cabinets coming soon. So once that comes in, we have to move this to that surface.
So prior to moving it, let it turn off and let it come up to room temperature. In the software I'll show you later, there's a signal called flange temp. Flange temp is the inside the cell. So this is what the cooling head looks like. Lift it off. So the flange temp is around this base underneath inside there. So that flange temp with the cooler fully heat or fully powered up and all the stages, because there's a two-stage compressor in here. So you'll turn it on, about 10 minutes later that second stage compressor will come on and you'll hear another kind of fan sound, and then it'll start actively cooling it, and then you'll see that flange temp start to drop. So sitting idle, you should see the flange temp around like -80. So the instrument won't let you start until the flange temp's around -80. So it takes about 10 minutes for this thing to get fully ready for a test.
So what is this temperature?
That's just the cell temperature, so your sample temperature inside of the cell.
It's sample temperature.
So if you ever were to move this, you would have to turn this off and wait for that flange temp to be back up to standby before moving this, because this arm will be frozen cold with liquid nitrogen. So if you move this arm when it's cold, you can fracture it. That's why you always want to turn this off and let it get up to room temperature again. It takes a little less than an hour to get it from there. So when you do go to move it, just make sure this is off and had been sitting for a
ambient
little bit.
temperature so we need to wait for
Yep. And if you did ever need to take this off, you may find it's going to be a little tricky for you guys. You may have to recalibrate T1 because it'll be probably kind of hard to get this moving with this at the same time. So you're probably going to have to take this cooling head off to move it onto the new cabinets. So the way to do that is there's a plug right here. It's connected in. So you disconnect this event plug right here. That will just pull right out from that connection.
this connection.
It's a heater. So this heater right here. You disconnect this heater connection from this connection right here. There's a little plug. I'm not going to unplug it right now. But. So you unplug that, and then there's 3 screws on here. 1, 2, 3.
So we need to unplug all of this. Yes.
See, nope, just this. The only thing you unplug is just that.
Just unplug that.
And then the 3 screws right here. 1, 2, 3 in the base.
And
the way you-
I'll
I'll show you the tool for it.
Tune this stuff.
So this is a tool to remove that cooling head. There's these 3 screws, and you just loosen all these up until you can feel this cooling head pull off. And you just have to be careful when you install it again and you have it centered on there when you push it back down.
Yes.
And also you have to be a little careful with this line when you orient it, because this line, you kind of have to go with the flow with this and make sure you're not putting excess strain on it. So when you do go to move it, you power this off, let it get back up to room temperature, unplug this, take off those 3 screws, and then this thing will just slide right off of the cell. So you just have to be careful not to nick the cell when you're pulling this off, as well as not to mangle up the graphite gasket that sits on inside of this opening. This screw right here. So with this tool,
And this one.
just do 1, 2, 3. I'll pull that off. And that's really all you have to do to move it. Once you get that off, then you should be able to move it pretty easily. So on the cooler, you have your power on and off, and then you have a manual and a vent. Manual mode is just always running. A vent is triggering the cooler on and off from the software. So it's probably better to have it on a vent just because you can trigger it in the software and it gives you some more functionality that way. So
This is just indication.
it's cool.
So what is difference between gas 1, gas 2 and cooling gas?
So cooling gas is if you had a different type of cooler, instead of using this one, there's a thin air cooler. It's basically just a metal baffle that goes on top of there instead of this cooling head.
I mean the cooling gas, it means refrigerant for this one?
No.
Something
It's
else.
just like gas from a tank, either air, nitrogen, anything basically just to blow air in it, just like blowing air to cool this baffle off.
Yes.
Like you don't have that cooling
Function.
accessory. It's a different accessory than this one, so you don't need it for this.
Okay, so actually we don't use the cooling gas.
Yeah, you don't need use cooling gas for this accessory.
That's gas 1 and gas 2.
Gas 1 and 2, you always have an inert gas on gas 1 because it's going to be purging an inert gas around this cooling head to keep it dry and free of any frost buildup. So they always want an inert gas for that. Gas 1 will split into the sample and into that base purge, which is what I was talking about to keep this dry. And then gas 2 is a switching gas, so you can, during a test, you can choose to go switch between gas 1 and gas 2.
We can switch.
Yeah, you can switch. So if you wanted to run it under oxygen, like you're doing oxidative testing, OIT stuff,
Yes.
during the test you can say switch to gas 2, switch to oxygen, and you can expose your
Yes.
sample to oxygen that way. So it's
So
going to
while both are connected, we can switch. Or
only while we're connected. You can't do any, if you only have gas 1, you only have gas 1, you can't switch to anything.
Yeah.
It won't do anything. Some stuff on the touchscreen. System info, basically it just has your networking. Right now I have the router that you saw, so it's set up for automatic addressing, so it'll find the IPs themselves. So this also has like your serial number. If you ever have issues with it, I may ask for your serial number, or for any other random stuff, I ask for serial number for getting a contract or any kind of thing like that. About just has like the board info. This button is a back button. This home button will bring you back to this main screen. This will just show you like the active program method. A lot of this stuff's kind of useless because you can see it on the software method you have, and the computer's right here, so it's kind of useless to have it in the screen.
What methods for what?
This just shows you the actively programmed method. So whatever steps you have on your run, it'll show up here. Like I said, it's kind of useless because the computer will have that on
Exactly.
for you. So there's really no need to
So
look at
it's
the
just
screen.
additional
Yeah,
extra.
I don't know why they have it. It's just more stuff to look at, I guess. Settings, this is where you can choose to turn off your cooler. Again, you can do this from the software, so it's just another way to do it. Same with all this stuff, you can go from the software. Air cool is if you have that other cooling head, and that's where it would activate that air cooling that you guys were asking about. And this is the standby temperature, so you see it's sitting at 40°C. Before and after runs, it'll go back to that 40°C. So you could change it from here if you want. And again, you can change that in the software as well. Utilities, so this system health, if you have any issues with any of the boards or anything.
So we can change initial temperature.
Yes.
I mean, our desired temperature will be provided by device.
What do you mean?
So right now, initial temperature for the sample is 40. So for an experiment, I need to reach like 20 centigrade temperature for my sample. So you can set 20 centigrade and 20 centigrade.
Yeah, if you set that as 20, it'll drop down to 20 and hold it there
Yes.
prior to the test.
Okay.
And after the test, it'll go back to
Yeah.
that 26. Diagnostics is just more signals. This is more so for my use. This, you really probably wouldn't ever use this stuff. One thing
this
you-
diagnostics. So what is this temperature? So what is difference between this temperature?
This is just for, more so for troubleshooting this stuff. If you're like cell breaks, this is what I would look at. So it's really not too useful for you guys to look at those. The one thing you probably use is a shutdown. This is how the proper way to turn off the instrument would go into here. Again, it's under utilities, shutdown, and then the screen would go black. Wait about 15-20 seconds, and then you can flip the switch on the back over here, by the power switch. So the power switch is right over top of this power cord. So if you did ever have to turn it off, like when you go to move it, this is how you do a proper shutdown of it.
Yes.
This is just a sample prep area. This thing is just a plug. So on the higher end models, you would have an auto sampler that has a waste bin. Since this is the lower end one, it doesn't have the auto sampler, so there's no point of having a waste bin, so this is just a plug. That's pretty much it. The functionality of the touchscreen. You go to open the software up. Our software is called Trios for this instrument.
And this is your card, correct?
Yep, that's it.
Correct.
So when you go to open up this instrument, you control from the computer. This is how you would open it. Trios. Double click on this. This is just the installation file, so if you ever need to reinstall it, it's on here. So every time you open it up, you should see this instrument with the green circle. That means everything is connected as far as networking goes and it's good to go. And then you can either double click on it or click connect here. If you see an icon that looks like a little person on there, it means someone else is connected to it. So if you do see that and it's not open, then you would just have to go into the task manager. It's most likely like an instance of the software still running in the background. So you just go into task manager and close it out. And then you should see it go back to that. And if you hover over it, you can see the serial number, the IP address, all this kind of stuff. This is for the Windows search. So there's a feature on this that doesn't work because of this older operating, because we have a 32-bit. This computer is 32-bit instead of 64. So when you open the software up for the first time, this is what you'll see. Sometimes you may not see this control panel. So this is the stuff that I was talking about on the touchscreen that you control. So your standby temperature, you can turn on your cooler. So the cooler is the RCS 90, refrigerated cooling system is what that RCS stands for. So you can choose to turn it off in the software. If you do have this not showing up, you just go up to the top here under experiment. So you have these two tabs. Go up here to controls, and this will pull this back up. And you can choose to expand this or make it smaller depending on what you want to see. Once you get your gas on, the thing to check would be the base purge. So if your gas isn't on, this would be 0. So this is what that the nitrogen is purging around the cell to keep it dry with the cell head, the cooling head. Your actual sample is seeing 50 milliliters a minute, so you see cell purge. So the total flow would be these two combined, so that's how much nitrogen you're going to be using a minute. So that's something to consider because you're running off a canister, so you have to be mindful about your usage. So if you're going to leave this nitrogen on like 24/7, you're going to burn through tanks. So just be wary of that and probably turn your nitrogen off after using it, if you're done using it. And you may want to turn this off as well.
Once you're done,
and this base purge should always be around 300 to 400 milliliters. If it drops below 200 milliliters, you'll get an error triggered in the software, so just go adjust it from that valve and just turn it up slightly. And again, this max PSI is 20, but usually it's around like 15-ish is what you'll have the pressure set out. Because if you have it around 20 or more than 20, you'll hear air coming out the back of that. That's from the pressure relief valve because it's a 20 psi pressure relief valve, so we'll start leaking out air from the back of that valve. And if you turn it up even louder, it'll start hearing like a kind of screech sound, so you'll know if something's wrong. But if you have it just slightly over, it'll just sound like there's air leaking out, so just be careful of that and just adjust the pressure accordingly. You kind of use this base purge as a way to adjust it. So right now it's around 389 milliliters a minute. That's good. Again, if you were to have an error with it, it would trigger an error. It wouldn't let you start a run or anything until you fix that condition.
So base purge should be around 0. It should be 0.
Base purge?
Yes.
No, we want base purge around 300 to 400 milliliters.
3 or 4.
It's at 389 milliliters right now, so we need that base purge because it keeps the cell cooling head dry and keeps the frost out, so you don't clog up your lines or anything.
Yeah, gas flow rate.
It's for best performance of the RCS. So again, if you wanted to change your standby temperature,
Yes.
this is how you would do that. Enter it in there, turn off RCS. You can also change your flow rates.
Control panel. It's control panel. Okay.
Yep. So to change your flow rates,
What is RS90?
RCS 90 is this cooler.
The cooler.
RCS stands for refrigerated cooling system. So that's what this is, RCS 90. If you click this button, it'll turn off the
Oh,
cooler.
okay.
So if you look here, the flange temp, we're sitting at like negative 86 right now. So this at idle temperature, standby, again, this should always be around negative 80. If you don't see it there, if it's at room temperature, then check your cooler, make sure that's on. If you know your cooler's on, you may have an issue with your cooler if that's not reaching around negative 80. It will change when you go to run a test, so when you go up to 400C, it's going to go up to like negative 40-ish, because the flange temp, the cooler can't maintain it. So if you're going to run a test up to 400C and hold it, it's definitely not ideal because that cooler can't maintain that high of a temperature for that long. But generally, when you run a test, it's going to drop right now because we turned it off and turned it back on. But like I said, ideally it should be around like negative 80, negative 70 when it's just sitting standby. If you did want to change your gas flow rate, default we have at 50 milliliters a minute. That's sample purge. That's what that cell purge is at the top.
The cell purge should be always 50?
Yeah, that's the default. So you guys can change that if you want, but usually best performance, I think we recommend 50 milliliters. If you wanted to change it, you would just enter it in this box down here under gas 1 to change that.
Base purge?
Yep.
Yes, nitrogen.
So once you get all that prerequisite stuff.
What kind of metals?
So these are all the gases you can run. Oxygen obviously not inert gas in there. The ones that you can run usually are nitrogen, helium, and argon are the three you can run with this for inert gases. Don't move that while it's running.
Not bad for my hair.
You can change it a little bit.
That's okay, that's okay. Yeah, I can move this to the side a little bit.
You don't want to move this line when it's cold because that's how you fracture it, like I said.
Oh,
Yeah.
okay. Oh, okay. Well, I still have warranty, honey.
Not that I saw you do that. Can you see it better now?
Yeah,
Sorry,
it's good.
I
It's good.
Yeah,
It's
it's
good.
good.
It's good. It's good.
Alright, so yeah, once you get all that programmed in, you come over here to set up your actual run. The way you do that, under here, under the experiment tab, we have 4 tabs over here, so you always set up your run in this experiment tab. And under here at the running queue, this is all the active runs in the sequence. So these are the only runs you can run. So you would start this run, it would go, finish the run, go back to standby, and then whatever other runs you have programmed in here. After that first test is finished and back to idle temperature, it would clear this run out. And then it would go to the second run, you would hit start, it would go to this run, finish, go back to idle, clear out of this running queue. So once you're done all these runs that you had programmed, it just empties them all out. One way to kind of store these runs is you can design them over here in this thing called the design view. So it looks very similar to this running queue, so a lot of people get these confused. But the difference between these is that you can only run in the running queue. The design view will hold it there. So if you program a bunch of stuff to run here, close out the software.
What is the difference between design view and running queue?
Running queue is the ones you can actually run, so you can't actually do any runs.
Running queue. I don't understand the next one.
Design?
Yes, design view.
Yeah, you can't. It's a way to create runs and hold them. It's like a way to store runs there. So every time you come into the software, it'll save those runs in the design view to put into the running queue.
Yeah.
So the order in the design view represent the sequence
Yes.
of the
Sequence of
experiment.
runs.
No.
I think no.
No. Design view is just a way to create runs and store them there.
Yeah.
Like if you're running a test in the running queue.
Running queue is sequence, based on sequence of.
This is your sequence.
Yes. But
So some people don't even use running queue. You don't even have to use running queue to run this. It's just a place to design it. That's why they call it design view.
Okay. So for the running queue, each run can only for each sample, or it is just so only one sample.
One sample. You're not going to want to rerun the same sample. So if you have the same sample, you're going to want to make a new one each time. You're not going to want to rerun the same sample every time.
So
Each sample is meant to be thrown away after you run it once.
Yeah. I'm asking is for this run that's one, right? Can I program in the way that you're gonna run sample 1, then sample 2, sample 3?
Yeah.
Or
yeah. You would have these all in here. So you sample 1, 2, 3, 4 in here.
yeah, 4 round 4.
You can have more than that. You can have a bunch of them.
Okay, so each sample has to be one run.
Yeah.
Each sample needs a new. Each run needs a new sample.
Correct.
Yeah. Okay. Yeah. Okay. Makes sense. And the order of that is a sequence from top to bottom, right?
Yep. So 1 to 10. You can move, click and drag to move them around if you want.
I see.
A lot of the stuff on this software you can get to by right-clicking. So you see me right-click a lot when I'm playing around with this.
Seems pretty easy, user-friendly.
Yeah, they try to make it pretty similar to like Windows controls with all the right-click stuff. So it's pretty intuitive for most of the stuff. The hardest part is when you get into like the analysis and playing around with that. There's going to be a learning curve a little bit.
So what happens if you stop during running?
What do you mean? Why would you stop during running?
Yeah, I mean, so if you stop the machine during running, I mean,
if you stopped it, it would go. I think it would go into the incomplete queue. If you can stop it here. Stop after current run. You get some options. So stop immediately. Stop after current run. Stop and continue to the next. So depending on what you click, if you were to click this during a run,
then we can use that sample or not. Then we can use that sample for a new run or not.
I probably wouldn't. If you stop it in the middle of the test, I'd say get a new sample because you've already exposed your sample to half the test, so it's going to change your sample. So I wouldn't recommend that. So when you come in here to create new run, you saw this button right here, create new run. You click this, and then you come in here. You program your sample name, your sample weight. So you're always going to want to have a balance to weigh your samples out. So depending on the type of sample you have, you're going to have to figure out a method that's best for you guys to load and weigh up your sample. So I saw your balance in there, so you'll probably be using that to weigh up everything. Obviously tear out your balance. Some people like to use the pans as like a little tearing tray. So the pans we give you are called the T0
This one?
aluminum. So these are the pans that come in your kit. So I think with the samples that you described to me, I'd probably recommend just the regular T0 pan and lid. So, So with this, you don't have to weigh up the pan, you just need your weight of the sample. So what a lot of people will do is take this pan right here, kind of use it as a weighing tray. So they'll take this over to their balance, tear this pan out on there, and then load their sample directly into that pan. Okay.
So we can order this from PA Instruments.
Yep. If you look inside on the lid here, it has all the part numbers to reorder this stuff with the descriptions of what it is. So you'll have T0 pans, T0 lids with the part number. So you would take that to the service helpline or purchase orders email address, order it directly from them. So whenever you make a sample, you'll have a pan and a lid. So you see right here we have our T0 hermetic and our T0 standard lids. So this is the pan, and then we have our lids. If you notice, they're color coded, so blue and black. And then on here is also blue and black. So this pan right here, you can use it with both of these types of lids. So the pan right here again is this, and then for your lids, you'll have these guys. So if you want to,
That's the lid.
so this is the lid for this pan.
Mhm.
That's the standard lid. So this is probably the one you guys will be using for your samples.
Mm-hmm.
Hermetic lids are hermetically sealed, so it's kind of like a cold weld onto the pan. So usually it's for aqueous samples. So I think with you guys, you'll probably just be using these standard lids for, these are your more general use type of pans.
Not aqueous.
Yeah, so this is what your pan and lid will look
So
like.
what to do for aqueous samples?
Aqueous is these lids. It's just a different type of lid. So that's the lid that goes on top of there.
Oh,
So you
yeah,
put this lid on top of this
That
pan.
one is for liquid sample, that one is for this pan, this is lids. Lid for liquid, lid for...
I mean, the liquid is at room temperature.
This for
Liquid,
which,
right?
for this pan?
Usually, I think you-
sample inside.
What kind of
For
liquids
example,
would you be running?
very small,
Well,
between
some of the
40
material, like a
between-
phase changing material,
So if you have
it's like a
and then
polymer
you need
type
to,
of thing. Some of them
close
can,
this lid.
depending on room
If
temperature,
your
right?
sample
So
is
if the
somehow
room
aqueous,
temperature,
you need to use this
well,
lid. If your sample is
Um, well, if you flush it a little bit, then we can change, like kind of something like an oil, you know, like maybe say like coconut oil, for example. When temperature is a little higher, like right now,
You could probably do that. It would just kind of be hard to do it because you'd have to load it really quick and then get it into the cell because I guess it would change temperature when you have it exposed to the atmosphere, right?
yeah.
So I guess that'd probably be something to experiment with. I don't know too many customers that have done that. They may have. I'm not really too sure. My experience is just service related stuff. So I'm the service engineer for this thing. I handle like the installations and any kind of like anything that breaks or anything. That's what I usually handle. So I don't see what customers are typically running most of the time. So that's why I can't really make an assessment based on that.
Okay.
You may be able to. That'd be something to talk to the applications people about.
Okay. But in general, that is for liquid.
Aqueous stuff.
What if this one has something like if you add some nanoparticles, what kind of
Somewhat.
nanoparticles?
Metal particles?
Yeah, some small, solid particles inside. It's still considered as like if it's like overall like a liquid phase, right?
Yeah, I'm not sure. That's a good question. You may be able to run it in the standard pan. I think you could probably do it in the standard pan.
Okay. I guess why they designed two different lids is for what kind of consideration? Expansion or what?
Pressure.
Pressure.
Yeah.
Okay.
Pressure and volatility.
Okay.
For the volatile sample, then sometimes you don't want to have it. You want to have it in that enclosed.
So what happens if you put it in the wrong type of container and you put it in the machine? Does the machine give a warning or something?
No, it's not smart enough to know that.
Okay.
No.
Okay. Would that cause any issue, like if it's
I mean, it
popped
probably
open?
could cause an issue with contamination, I guess, if you're having something boil off. Something's boiling and then it spills
Yeah.
over your pan, it could contaminate your cells. That's
Okay.
something to consider, I guess. With that.
Okay.
So, if you notice on the pan, you'll have these two color codes. So that's saying it's for you can use this pan type for the standard lid and the hermetic lid, because these are color coded as well. And these color codes correspond with these press dies. So if you notice, the black and blue are for these dies right here. These dies are for this pan press. So whenever you create a sample, every time you create a new sample, you're going to have your pan press to press the samples in. So if you look in here, in this lid it'll tell you what each one's for. So we have our hermetic and our standard. Again, hermetic is the one for the aqueous liquid solutions samples. And you'll notice with these there's a top and bottom piece. So this one was just in the top right here, and then this is the bottom piece. So whenever you get your sample in here, you'll put the pan in here, and then this pan will press it in. So this is just pressing that lid into the pan. And with these, there's two top dies because you have different sample geometries. So there's one that's flat and one that's more like concave. So depending on how your sample is, you may find that these may work better for your use. This is magnetic, so you always put the top piece in first.
Oh, by the way, you said the two top press, it goes, both of them is the same size for what you just showed us, the top lid.
You mean same size?
It looks like the two top press, the shape is a little different. Diameter is a little different.
Everything's the same, it's just shape. So if your sample is a different shape, if you have like a bulkier sample, you may find that one would work better for it.
But you use
This
it for
one's
the
more.
same.
This is more for like powders. This is more for like block of material. So you have like a polymer that's like a square block cut off. This may be better for that. If you have like a sample powder or something like that, this will probably work better for that type.
Okay, and doesn't matter which type of the top lid you use. The same top lid.
Are you talking about the lids?
Yes, yeah.
So the lids, these are the black dies. So this corresponds with the black on here.
Okay.
So this is standard lid for these dies.
Oh, okay.
These dies are for the aqueous solution. So think blue, think water, think aqueous solution.
Yes.
So that's what
For
these are
aqueous.
for.
So what about white and green?
White and green are for old pan types. So you don't have these old pan types. I recommend using with the T0. We did used to sell an older version of these pans, which has worse, I guess, results. These have better performance, so I recommend sticking with this type. So I wouldn't even worry about these if you're going to stick with this type. So that's what those old ones are for. So this would be hermetic, so the aqueous for this old style, and standard for this old style.
And aqueous standard.
Again, if you look in the lid, it says what these are for.
There is no explanation what regarding the application.
TA hermetic. For application of them, this is how you would find this. So this is in the help section. If you go into the software at the top here, help, search up sample or anything. You can search by keyword in here and it'll pull up a bunch of different topics for you to look through. So this is really useful tool. Probably the most useful tool in the software for getting started. So selecting a sample pan, this is where it talks about how to make the correct pick for what your sample is. So I'd recommend looking through this. But I think with your sample, you'd probably be good with the standard. But again, I'd probably just read through that just to make sure. And if you have questions, then you can contact the applications people who are there are PhD level like chemists, so their background is way more knowledgeable than mine as far as this higher level stuff goes.
If we got some problem in running the machine, simple problems, so can be contacted?
Yeah, that would be me. So like I said, I'm the service guy, so any kind of simple stuff like that, like if you suspect it's something as far as that, like boards breaking, this thing not functioning, any kind of that stuff, you go to me for that.
Yeah.
Or any kind of like warranty
for the
thing,
questions, so what is the best contact way to you? Email or text
For
you?
email's fine. Calling is okay, but a lot of times I won't have service on site, so honestly I prefer email or text is fine. On my card you have my cell and contact. And then the thermals.
Just to clarify, so this one here, you said is recommended for powder.
Yeah, the powders are.
And this one is for
bulky.
bulk
A little bulky material.
Okay. And they use the same lid. Doesn't matter. Okay.
Yep. Same lid.
Okay.
The same lid.
Just different sample geometry, same lid. So always just use this as a reference. So if you're going to be using this T0 lid, just look at that black and know you're going to be using those black dyes.
So want to make sure we keep it in the same, don't mix it.
That one is concave. And that one.
That's the bottom die.
Is the bottom?
So with this, there's always two dies. So this is the bottom, this is the top. So when this press comes in here, your pan's going to sit in here, it's going to come down and press that lid in. So when you go to load this up, you put your top die in. Right now I'm just going to make...
So there is something, can you please remove it?
Sure. It's magnetic.
Oh, it's
Yeah.
magnetic. Okay, yeah,
Yeah.
I know what I'm saying.
This
So you'll want to
is-
have it in the open position. So there's two positions, open and closed with this. Open and closed. So when you go to put that top die in, you want to have it open. You'll see this little
the sample
piece
is
come
here.
down.
So let's say the powder is here. Okay. Now I need to.
No, that's
install-
That's the
the
top
top.
die.
That's the quality top.
That's
This
the
is the
Yeah. Now here, like here, and then goes to here. Yes.
No, you want to always put the top die in first. So when you go to do this,
Uh-huh.
top die in first.
It's magnet. Yes.
Yep, it's magnet, so just put it in there. You'll feel when it's all the way in. I kind of rotate it just to make sure it's sitting properly.
Yeah. Okay. Now, so you can put this in.
So I'm assuming this is the top. This is the bottom.
So
This is the bottom.
when you go to make a reference pan, again, the reference pan is the, it's going to be this one's a little manual using one. Your reference pan is always going to be the same type of pan as your sample. So the reference pan is just an empty pan with the lid on it.
Now, my question is that how to weigh the sample to make sure between 5 milligram and 10 milligram.
With the balance, you can use, I think we give you,
I mean, it should be a very accurate scale.
yeah, I don't know what kind of scale. I saw the one over there in the corner. I'm not sure how
Yeah.
accurate it is, but
Yeah, there is one outside. I forgot the resolution. Yeah, we can get that. See, biggest of it.
so to make just a regular standard reference pan, get your pan and your lid, make sure they're not mangled up, and then you would just put the lid inside of this pan. Sorry, it's so small, it's kind of hard for you guys to see, but
Yeah.
you would put that lid, this is the standard lid, this one's mangled so I didn't use it, but you would just put that lid on top of this pan, make sure that it's seated in there properly, like it's not cocked to one side or seated upright. So you should see it like that before you go to press it. So once we got that lid in there, come over here to this press, just put the pan in this right here. Make sure it's flat in there. And then bring it over here to the press. Put the press in the up position. Put the bottom die in. I usually just rotate it to make sure that it's seated properly. And then just do like a visual inspection, make sure that pan is still seated in there properly, everything's good, and then you just do that. And then your pan's pressed, simple as that.
It's just for press. Okay.
And now we have our sample or our reference pan made. So you would follow the same procedure when you're pressing a sample pan, but obviously you'd want to weigh up your sample beforehand so you don't press your sample in there without knowing its weight. So you weigh up your sample, put it in there, do the same procedure, put your lid in there, and then just put the die in, press it, and you're good to go.
Will you run a sample?
Oh yeah, we will. So we're going to do an indium.
Is one of you?
Indium.
Indian.
So indium is the material we use to calibrate this with. So that's probably the main material you guys will be running to check the performance. Indium we use the temperature and the the enthalpy value. So indium will melt at 156.6 and 28.7 is the joules a gram is the enthalpy that melt will generate with the heat. So we use those two values to calibrate the DSC with. So what you do,
Yes.
hopefully that balance is working. You take one of these guys out. Trying to get around 5 to 10 milligrams of this indium sample.
You need to weight it. You can bring that scale.
This one over there.
It's so hot, man. It's too hot.
Oh, right, wow. This side. Open it here. What you do with all these things used to be on the shelf for making a sample chemical?
All are in here. Anything we remove from cabinet.
No cabinet. On that, on the other side, by the wall. On the wall where you have all the cabinets. All the cabinets. Don't worry about it.
Okay.
I'll just use a pen. It's all good.
Okay.
No worries.